earthquake measuring 6.0 on the Richter scale, which is 1 point higher than yesterday's, has struck Kuching earlier today, sending shock waves across the region and causing widespread concern. Our correspondent Faith is on the ground with more details.
I'm reporting live from Simon University, where a 6.0 magnitude earthquake struck at approximately 9 a.m. This tremor lasted for nearly 67 seconds, rattling buildings, triggering panic among students and staff, and causing moderate structural damage.
Gabriella, 1 point increase only. Hiya, why they make such a big deal?
No matter.
A 5.0 earthquake is very different from a 6.01.
Let me show you.
The magnitude 5.0 and 6.0 refers to values on the Richter scale, which is a logarithmic scale developed in 1935 by American seismologist Charles F. Richter. It measures the strength of an earthquake based on the amplitude of seismic waves, in other words, how much the ground shakes. The Richter scale calculates the magnitude of an earthquake by comparing the seismograph reading I recorded at a distance of 100 kilometers from the epicenter to a baseline reference reading I0. The formula of the Richter scale is R equals to log I over I0, where R is the magnitude of the earthquake, I is the intensity of the seismic wave, and I0 is the reference intensity, which is usually given as 0.01 millimeter. Now let's calculate the difference in intensity between a 5.0 and a 6.0 earthquake. First, substitute the magnitude of the earthquake into the formula of Richter scale. Assuming I0 is unknown in this situation, we write the equation in exponential form. Solve each equation for I0. Since both equation equals I0, we can set them equal to each other. Lastly, solve for I of 6.0. The result means that a 6.0 earthquake is 10 times more intense than a 5.0 earthquake in terms of wave amplitude. As mentioned earlier, the Richter scale is logarithmic. That means each whole number increase represents a tenfold increase in wave amplitude, as we have just demonstrated through this calculation. Next, let's calculate the energy released by the earthquake from its epicenter, using the formula log E equals to 4.4 plus 1.5 R, where E is the energy release and R is the Richter magnitude. First, substitute the magnitude into the formula. We write the equation in exponential form. To compare the two values, divide the second equation by the first equation. Lastly, solve for E of 6.0. The result shows that a 6.0 earthquake releases about 32 times more energy than a 5.0 earthquake. In conclusion, while a difference of 1.0 on the Richter scale may sound small, it's not a minor change. The increase of 1 point makes the earthquake 10 times more intense and releases about 32 times more energy.
Wow, Gabriella, so smart. I understand now.
After 2 consecutive earthquakes in a row, the number of victims is expected to increase tremendously.
This is so bad. I can't imagine how bad the situation there really is.
Actually, Mother, I think I know how they can count the number of victims affected. We can calculate it by using the exponential growth formula.
By using the exponential growth formula, Pt equals to P0 times e power 2 RT. Pt equals to population at time t victims. P0 equals to starting number initial victims. R equals to growth rate percentage increase or decrease. T equals to time, days, hours, etc. E equals to Euler's number 2.7. For example, if the first earthquake left 5,000 victims and the number of victims increases by about 20% per day, then after 3 days, initial victims P0 equals to 5,000, growth rate R equals to 20% per day, 0.20, time T equals to 3 days. By using the formula, Pt equals to P0 times e power 2 RT. P3 equals to 5,000 times e power to 0.2 times 3. P3 equals to 5,000 times e power to 0.60. P3 equals to 5,000 times 1.822. P3 equals to 9,110. So, by day 3, there may be about 9,110 victims, almost double the original 5,000. Authorities would need to prepare hospitals, shelters, and supplies for nearly twice as many people in just a few days.
I see. You both made me realize that maths is so important and it can use in so many aspects of our lives.
Yes, Mother. Mathematics can be used in building infrastructure, prescribing the correct dosage of medication, and everyday life activities like calculating the prices of items after discount, which you are so good at.
So sad that many people still think that maths is boring and useless. If only if they made it more relevant to their lives by connecting it to real-world problems like we did earlier. They should also apply and relate it to their interests, whether in gaming or even music, to see that mathematics is everywhere in our lives.
Can you imagine mathematics solving all the significant problems of our lives? For health crises, maths can help estimate disease spread and even vaccine development. Through maths, poverty and hunger could be solved by optimizing food distribution and resource planning. The possibilities are just endless with maths.
Are you making a maths commercial, lol?
The next thing you know, she'll say, this was brought to you by logarithms and indices. So sad that many